In this video, we're briefly going to talk about even and odd functions. So even and odd functions. So even and odd functions are important in many areas of mathematics. They come up, if you take math classes, they come up in multiple classes. And I guess this is the point where you're supposed to learn about them. So a function is even. Let's talk about that first. So f is even if, so algebraically this means that if we plug in negative x, we just get f of x. So it eats the negative signs, and this has to be true for all x in the domain of the function. Graphically, this means that the graph of f is symmetric, and let's use some fancy terminology, with respect to the y-axis. So WRT means with respect to. So let's look at a simple example so you see how this works. So maybe the simplest case is f of x equals x squared. So in this case, algebraically, if you plug in negative x, well, that just means you replace all of the x's with negative x. So you get negative x squared. And since this is the first example, let me actually show what happens. So this is equal to negative 1 times x quantity squared, right? Because negative 1 times x is negative x. And then using properties of exponents, you can write this as negative 1 squared times x squared. Then negative 1 squared is 1. This is beautiful, beautiful stuff, which is just x squared. So we have f of negative x equal to x squared. But x squared is what we started with, right? So that's just f of x. So we showed that f of negative x is equal to f of x. And this is true for all x, so the function is even. That's pretty much a proof. Now, we don't have to prove things, but I wanted to show you so you see how to do it. It doesn't hurt to learn a little bit more. Basically, whenever the exponent is even, if you have only even exponents, stuff like this, stuff like this, it's always going to be even. So if all the exponents are even, the answer is always going to be even. Graphically, it's symmetric with respect to the y-axis. So here's the y-axis, and this is called the parabola. F of x equals x squared. This is the graph of that, and it's called a parabola. And so basically, if it cuts it in half, the y-axis cuts the graph in half, so you get the same thing on both sides. You can also think about flipping it across the y-axis, and you would get the same thing on both sides. So to summarize, whenever you have just even powers of x like this, the answer is going to be even. It's an even function, and it's symmetric across the y-axis. Let's talk about odd functions now. So f is odd if, well, whenever you plug in negative x, you get back negative f of x. And this has to be true for all x, in the domain of the function. The classic example here, and graphically, what does this mean? This means that the graph of f is symmetric with respect to the origin. Okay, so let's talk about what that means in this example here. So f of x is x cubed. That's the most basic example we can look at for an odd function. And using the definition, if we plug in negative x, we would get negative x cubed. And then because it's odd, the negative is going to hang out. So this is negative. And then this piece here, that's f of x. So that's just negative f of x. So algebraically, we start with f of negative x. We end up with negative f of x, so it's odd. Graphically, it's a little bit harder to see when for odd functions. Okay. So that's the graph of x cubed. So why is this odd? Well, if you rotate it across the origin, you should get the same graph. So that's hard to visualize. So maybe a better way, let me fix this, make it a little bit smaller. There we go. Maybe a better way to do that would be to flip it twice. So if you flip twice, make this a little bit bigger, flip twice, you get the same thing. So flip twice, you get the same thing. So for example, if I flip it once, it's going to look like this. And if I flip it again, it'll look like this. So if you reflect it across the y-axis, and then you flip it again down to the x-axis, if you go this way, then you go this way, you get the same thing. Let me try drawing it a different way over here. So this is the original. If you flip it down, it's going to look like this. Then if you flip it over, you get the same thing. So flip twice, same thing. That's what it means for a function to be odd. That's the easiest way to think about it. I hope that made sense.